Hey everyone, my name is John.
And I'm Rohan.
And together we worked on our final project for ECE 5413 Embedded Systems and Graduate Level Embedded Systems course here at Cornell Tech. Our final project was building an IoT-based parking sensor system. Effectively, what our project does is it has sensors that are able to determine whether or not a parking space is filled. That information is then transmitted to the cloud, which is then relayed to a screen that's at the entrance of the parking garage that says how many total spots are open at the garage, and then a text message is sent to subscribed users whenever a spot becomes available, if the parking lot had been full before, or if the parking lot is filled after spots had been available previously.
So let's just go straight into each component of our project. For the actual sensing of parking lots, whether or not they're free or full, we are actually using two ultrasonic sensors, which are currently, as they are, basically taken values and send them to an Arduino. Now this Arduino then segregates the distances and puts them as a 1 or 0, depending on the threshold that we set, and relays that information over serial to a Raspberry Pi. Now the Raspberry Pi is running a node server, which then relays the information to a Samsung Arctic IoT cloud, which you can see over here. Now the cloud itself is showing values in real time of both the parking spots. This is one of them, this is the other. As you can see right now, both spots are empty, and that's why both are showing a high signal. Coming to the other side of the system, we have an Adafruit Huzzah. It's an ESP8266 microcontroller that has Wi-Fi. So using that, we're actually connecting to the IoT cloud using an MQTT protocol, which is then receiving values from the cloud and then displays exactly how many parking spots are available at that current point of time. Using this value, we're actually sending a signal to an Arduino, which then tells a SIM900 to send an SMS over to a smartphone when there is a spot available or not. So that's basically how the entire system works. For now, we can show you a short demo of how it actually works. So
let's pretend that this shoebox is a car that takes up 2 parking spots. The box moves in front of both sensors, occupying theoretically both spots at the same time. As you can see here on our LED screen, you get a notification that says there are 0 spots available in the parking garage, and then on the cell phone you can see that we just received a text message that says, sorry, the parking lot is full, with a little sad face. Now, if one of these spots becomes available, let's say the car shrinks and it only takes up 1 parking spot, then you'll see on the OLED again that it's now incremented up to 1 spot available. And that we just received a text message saying that there's a space available. So go to the parking spot. And you can also see in real time, as we adjust it on the Arctic Cloud UI, and that as parking spots become available or not available. As I'm just randomly adjusting it right now, just to kind of show the changing in values. Now I have it set up so that both are available.
So that is essentially the core of our project, and yeah, that's about it.